Hello students, welcome once again to another section. Now in this section we have to solve for the real values of x if a is equal to 0. Now so let's do that. Now for a being equal to 0, when we substitute a, which is 0 here, then we have 5 exponent s here minus 9x plus 18, then plus 1, then we have 6s minus 3. This goes to 1. Then we have 5 here, s squared minus 9x here plus 18, right? So this will also cancel that, right? And we are left with 6 exponents, s minus 3, then 5 s squared minus 9x here plus 18. Now what can we do here? Now the question says we should find for the real values of x, right? Now if you look at this exponent here, right, we have x minus 9s plus 18, right? Now in expanding this, we can get 6 and also 3, right? So over here we can have s squared minus 6s minus 3s then plus 18. Now when we factorize out, we have x here minus 6 here plus minus that, then we have s minus 6 here. So we can have x minus 6 and also x minus 3 as the exponent. Now when we substitute that into here, so we can have x equal to s minus 3 here equal to 0, then x here is equal to 0. So we have x equal to 0. Now when we substitute s equal to 0 into the exponent here, let's do that and see what will happen. We have 3 minus 3 here, then we have 5 here, 3 squared minus 9 multiplied by 3 plus 18, then we have 6 exponent 0. Then when we compute this whole thing, then we should get 0 here, then we have 1 here equal to 1, right? So therefore this should tell us that one of the values of s should be 3, right? So we can get 3 in this case. Now let's check whether we can find other values of x. So in doing that, since we have 6 exponents s minus 3 here being equal to 5 exponents s squared minus 9x plus 18, then what we can do is to apply log on both sides, right? So applying log on both sides, we have log 6 exponent s minus 3, then also the log of 5 here s squared minus 9x here plus 18 here. Then since we apply log on both sides, in one log with log properties, if you have this exponent, it drops here, right? And this exponent also drops here. So let's do that. So we have x minus 3 here and the log of 6 being equal to s squared minus 9x here plus 18 here. Then we are left with the log of 5 here, right? So but first, when we apply the log, we must get a base, right? So applying the base on both sides, we take we have the base of 6 here, a base of 5 here, so we have to take the smallest base. So let's take the smallest base, which is 5. So we take 5 here, we take here to be 5. Then if that is the case, then what we are going to do next is, since we have 5 log 5 here base 5 here, know that 5 here base 5 here is just 1, right? So if that is the case, s minus 3 here, then the log of 6 5 here being equal to s squared minus 9x here plus 18 here, right? So s minus 3 log 6 here base 5. Now this alone is just s minus 3. We have established that all of this is just s minus 3 and s minus 6, so s minus 6 here. Now remember, we also have s minus 3 here, so we realize that s minus 3 the log 6 here base 5 divided here by s minus 3, right? So we divide here by s minus 3 being equal to s minus 3 here, s minus 6 here, divided here by s minus 3. This gets rid of that, and this also gets rid of that. Now what are we left with? We are left with the log 6 5 here being equal to x minus 6 here, right? So since we are looking for x, then x here will be equal to this log 6 here base 5 here plus 6, and basically this would be the x. So s can be the log base 5 6 here, and what we can have x here being equal to 3. So these will be the solutions for the values of s, or the real values of x. Thank you very much for joining me in this section. I hope this section was helpful, and if this is your first time here, please like, share, and also subscribe, hit the notification bell also, and I would meet you in another section.